begin Chapter 5, we're going to be investigating more information about quadratic functions. We already know some things about those. Everything that has an x squared is a quadratic, as long as you don't have any higher powers of x. You can have numbers along with the x squared. You can have more x's along with the x squared. You can have x's and numbers along with the x squared, but to be a quadratic, you got to have an x squared. We want to look at some of the other detailed information that we're asked concerning quadratic functions. Here is a typical quadratic function. If you look at the graph of the quadratic function, which you could do on your graphing calculator, we're trying to find the x-intercepts. That means where does it cross the x-axis. Now observe that the points where it crosses the x-axis have a y-coordinate of 0. And so that's our guide to what we need to do. Y is the same as f of x. So we're simply going to take the function, use a 0 in place of f of x, and then solve the quadratic equation, which we did before in Chapter 2. And so solving that, either by factoring or the quadratic formula, we get the two x-intercepts. To find the y-intercepts, it's a similar idea. Here's the graph of that function. We want to know where does it cross the y-axis. Well, any point on the y-axis has an x-coordinate of 0. So we're going to take our original function, put a 0 in place of the x, and see what we get. That's the y-intercept. The thing called the vertex means the very lowest or highest point on the parabola. In this parabola, since it's curved upward, we have a lowest point, and we need to find that. Now on the formula sheet, there's a formula for the vertex. You notice it's an ordered pair. The left number on the left is the x, and the number on the right is the y. So there's the x and y coordinate for the vertex. Now the A, B, and C, notice there's not a C, are the same things from the quadratic formula that we learned in Chapter 2. And so taking the x value, negative b over 2a, and substituting the numbers from the function, we get the x-coordinate of the vertex, and then the right side, the y, all that says is take the answer you just got and plug it into the function. So plugging 3 into the function gives us the y-coordinate. Now the vertex is a point, so we write it appropriately, x comma y in parentheses. Now we need to draw the graph. Now you can actually do a graph on your calculator, but the details of the graph you're going to need to know in order to construct the graph on the computer. And so let's see what we need to know. First off, we need the vertex. And we just saw we can use the vertex formula off of the formula sheet. So the x-coordinate of the vertex, plug that back in, y-coordinate of the vertex, we draw us a graph and put the vertex 3, negative 4 on the graph. Now we need to find one other point. The other point can be either the x-intercepts or the y-intercepts or anything else, as long as it's not the same as the vertex. And so in this case the y-intercept is pretty easy. Plug a 0 in place of the x and put a dot there. Now all we do on the computer is just locate those two dots, and it draws the rest of it for us. If you look at the graph, you'll see the left side of the vertex, the graph on the left side of the vertex and the graph on the right side of the vertex are symmetric. That means mirror images, identical shape, and that's a handy way of drawing the parabola. Now finally, I just want to point out that sometimes you'll see quadratic functions already written in this form, and it's real easy to determine what the vertex is without even looking at the vertex formula. If you've got in parentheses x minus 3 squared, and then outside of the parentheses plus 4, well, the 3 and the 4 are the vertex. Now remember, the signs are a little strange to deal with. Here, the 5 and -7 are the vertex. And on this one, if it's x plus 6, that is x minus -6. So the vertex would be -6 and 3.